Understanding the hunger satiety cycle. 1. Hunger. Hunger is the physiological sensation that signals the need for food. Several hormones and mechanisms are involved in triggering and regulating hunger. Ghrelin. Ghrelin is often referred to as the hunger hormone as it stimulates appetite and increases food intake. It is primarily produced in the stomach and released when the stomach is empty. Ghrelin levels rise before meals and decrease after eating. Neuropeptide Y, NPY. NPY is a neurotransmitter and hormone that stimulates hunger. It acts on the hypothalamus, a region of the brain involved in appetite regulation. Increased NPY levels can trigger the sensation of hunger. Hypothalamus. The hypothalamus plays a crucial role in regulating hunger. It receives signals from hormones and neurotransmitters and sends out signals to initiate or suppress appetite. It integrates various factors such as hormonal signals, nutrient levels, and emotional cues. 2. Satiety. Satiety is the feeling of fullness and satisfaction after eating. Several hormones and mechanisms contribute to the regulation of satiety. Leptin. Leptin, often referred to as the satiety hormone, is produced by fat cells and helps regulate body weight by signaling fullness to the brain. When fat stores increase, leptin levels rise and act on the hypothalamus to decrease appetite and increase energy expenditure. Peptide YY, PYY. PYY is a hormone released by the gastrointestinal tract in response to food intake. It helps reduce appetite and contributes to feelings of fullness. Cholecystokinin, CCK. CCK is released by the small intestine in response to food consumption. It stimulates the release of digestive enzymes and triggers a feeling of fullness. Insulin. Insulin, primarily known for its role in glucose metabolism, also plays a part in satiety. It helps regulate blood sugar levels and influences appetite and food intake. 3. Hunger satiety balance. The hunger satiety cycle involves a delicate balance between the hormones and signals involved in hunger and satiety. When we eat, hormones such as ghrelin decrease while hormones like leptin and PYY increase, signaling fullness. This cycle helps maintain energy balance and prevent overeating or undereating. The role of insulin in blood sugar management. 1. Insulin. The blood sugar regulator. Insulin, a hormone produced by the pancreas, is primarily recognized for its role in regulating blood sugar levels. It allows cells in the body to take in glucose from the bloodstream and use it as a source of energy. Here's a closer look at how it functions. Glucose uptake. After a meal, the carbohydrates you consume are broken down into glucose, causing blood sugar levels to rise. In response, the pancreas releases insulin, which signals cells in the body to absorb this glucose and use it for energy. Storage of excess glucose. When the body has more glucose than it needs for immediate energy, insulin helps store this excess glucose in the liver for future use. This prevents blood sugar levels from rising too high. Image. Insulin, the blood sugar regulator. 2. The impact of insulin on the body. The role of insulin extends beyond just blood sugar management. It has a significant impact on various aspects of our health. Energy distribution. Insulin helps determine how the body uses and stores calories. It directs whether these calories are burned for energy or stored as fat. Hunger and satiety. Insulin plays a role in signaling satiety. After a meal, as insulin levels rise, it sends signals to the brain to reduce hunger and promote feelings of fullness. Metabolic function. Insulin is integral to metabolic function. It helps regulate the metabolism of carbohydrates, fats, and protein. Image. The impact of insulin on the body. 2. 3. Insulin and health conditions. Imbalances in insulin can lead to various health conditions. Type 2 diabetes. This condition occurs when the body becomes resistant to insulin or when the pancreas is unable to produce enough insulin. This leads to high blood sugar levels, which can cause a range of health problems. Metabolic syndrome. Insulin resistance can contribute to metabolic syndrome, a cluster of conditions that increase the risk of heart disease, stroke, and type 2 diabetes. Polycystic ovary syndrome, PCOS. Women with PCOS often have insulin resistance, which can lead to elevated insulin levels. This can contribute to the development of symptoms associated with PCOS. How hormonal imbalances can lead to overeating and weight gain. 1. Ghrelin and leptin imbalances. Ghrelin and leptin, often referred to as the hunger and satiety hormones, respectively, play a crucial role in regulating our eating behaviors. Ghrelin. When ghrelin levels are high, we feel hungry. If the body produces too much ghrelin, or if we become insensitive to its effects, it can lead to persistent feelings of hunger and subsequent overeating. Leptin. Leptin signals to the brain that we are full and should stop eating. However, when we have too much body fat, leptin levels can become chronically high, leading to a state known as leptin resistance. In this state, the brain no longer responds effectively to leptin signals, leading to overeating despite having sufficient energy stores. 2. Insulin imbalances. Insulin, the hormone responsible for regulating blood sugar levels, also plays a significant role in weight management. Insulin resistance. When the body becomes resistant to the effects of insulin, it leads to higher levels of insulin in the blood. High insulin levels can promote fat storage and lead to weight gain. Additionally, insulin resistance can disrupt the normal functioning of ghrelin and leptin, further contributing to overeating. The impact of hormonal imbalances on weight gain. Hormonal imbalances can lead to a cycle of overeating and weight gain. Overeating leads to weight gain, which can exacerbate hormonal imbalances, leading to further overeating. This cycle can be difficult to break and can contribute to the development of obesity and related health conditions, such as type 2 diabetes and heart disease.